Okay, so the next topic is acceleration. Acceleration is denoted by A. And how do we define it? It is rate of change of velocity with respect to time. So again it is a rate, so we can say average acceleration. When we say average, it is denoted by delta. So average acceleration will be delta V by delta t. Now, how we deal with the x final x minus initial x, that is delta x. So delta V means final velocity minus initial velocity. So it will be called as V2 minus V1 by T2 minus T1, and instantaneous acceleration is denoted by dv by dt. And how to calculate dv by dt? We will see. If it is v is equal to t raised to n, so dv by dt will be n t raised to n minus 1. So let's do one question. If we say v is equal to t square minus 2t, find average acceleration in third second. When it is third second, what do you mean by third second? It means 2 to 3 second. First second means 0 to 1. Second means 1 to 2. Third second means 2 to 3. 2 second to 3 second means third second. And of course you can say nth second. Nth second means n minus 1 to n. So here I am finding third second. It is 2 to 3 seconds. So first we'll calculate what is the velocity at 2 second. So we'll put t is equal to 2 second here. So v1 is equal to 2 square minus 2 into 2. So 4 minus 4, that is 0. And v2, to calculate v2, we'll put t is equal to 3. So 3 square minus 2 into 3, that is 9 minus 6. So that is 3 meter per second. These are instantaneous velocities. This is velocity at 2 second. This is velocity at 3 second. So average acceleration is final velocity minus initial velocity by delta t. Now v2 minus v1 will find, that is 3 minus 0, and delta t is equal to 3 minus 2. So that is 3 by 1 meter per second square. This is average acceleration. Let's do one more question. Find average acceleration from 1 second to 3 seconds. So when it is average acceleration, we have to identify the initial and final time. That is, like for example here it is initial time 1 second, final time 3 seconds. So that is t1 and this is t2. Now we'll calculate v1. So v1 means put time is equal to 1 in this expression for v. So 1 square minus 2 into 1. And to calculate V2, that is final velocity, we'll put time is equal to 3. So that is 3 square minus 2 into 3. So we have V1 is equal to 1 minus 2, so that is minus 1. And V2 is equal to 9 minus 6, so that is 3. Now we will use the formula for average acceleration. So that is delta V by delta T. So it is V2 minus V1 by delta T. 3 minus minus 1 divided by 3 minus 1. So this is 3 plus 2 by 2. Oh, sorry. So V2 minus V1, so that is 3 minus minus 1 divided by 3 minus 1. So this will be 3 plus 1. This minus minus will become plus. So 3 plus 1 by 3 minus 1, which is 2. So that is 4 by 2 is equal to 2 meter per second square. So average velocity between 1 to 3 second is 2 meter per second square, and average acceleration between 1 second and 3 second is 2 meter per second square, and average acceleration in third second it is 3 meter per second square. So you observe how we are calculating average acceleration. We have to find change in velocity and change in time, then find the ratio. Change by change. Change in what? Change in velocity divided by change in time. That is average acceleration. Let's do instantaneous acceleration. So first we'll see the formula for instantaneous acceleration. It is a dv by dt. Now you have to calculate dv by dt. We will observe if v is t raised to n, so dv by dt will be n t raised to n minus 1. Suppose v is given as t cube. Find acceleration at 2 seconds. So we will apply the formula. Dv by dt will be 3t raised to 3 minus 1. So this is 3t square. Now we'll put t is equal to 3. So 3 into, now we'll put t is equal to 2. So 3 into 2 square. So that is 3 into 4. So that is equal to 12 meter per second square. So find acceleration at 1.5 second. So we'll say dv by dt is equal to 3t square. So 3 into 1.5 square. So 3 into 2.25. Then that will be equal to 6.75 meter per second square. Let's do one more example. Suppose if I say v is equal to root t, so no problem, it can be written as t raised to 1 by 2. And suppose question is asking find acceleration at 9 second. What is the acceleration at 9 second? So we will use the formula again. So v is equal to t raised to n. So dv by dt will be n t raised to n minus 1. Now what is the value of n here? N is equal to 1 by 2. So we have v is equal to t raised to 1 by 2. So dv by dt is equal to 1 by 2 into t raised to 1 by 2 minus 1. So it is 1 by 2 t raised to, now 1 by 2 minus 1 is minus 1 by 2. So when you have negative power in the numerator, that means the expression is in the denominator. Like for example, t raised to minus 2 means 1 by t square, t raised to minus 1 means 1 by t. So t raised to minus 1 by 2 means 1 by root t. So this will be 1 by 2 root t, 2 square root of t. Now here we will put t is equal to 9. So we are getting acceleration as 1 by 2 square root of 9. So that is 1 by 2 into 3. This will become 1 by 6. So acceleration is equal to 1 by 6 meter per second square. 1 by 6 meter per second square. Let's take one more example. If v is equal to 1 by t, find acceleration at 2 seconds. So dv by dt we have to find. Now first you make sure you write this in x power n form or t power n form. So it is t raised to minus 1. So dv by dt will be minus 1 into t raised to minus 1 minus 1. So it is minus t raised to minus 2. So the acceleration at time t will be minus 1 by t square. Minus 1 by t square. So find acceleration at 2 seconds. So at 2 seconds, acceleration will be minus 1 by 2 square, that is minus 1 by 4. That is equal to minus 0.25 meter per second square. We can take one more example. If v is equal to t square minus t cube, find acceleration at 2 seconds. Find acceleration at 2 seconds. So we will do separately. We'll separately differentiate t square and t cube and then differentiate. So dv by dt will be 2t raised to 2 minus 1. Then minus come as it is. Then t cube will be 3t raised to 3 minus 1 like this. So this is 2t minus 3t square. Now put time is equal to 2. So 2 into 2 minus 3 into 2 square. So 4 minus 12. So that is equal to minus 8 meter per second square. Now one thing you are observing in these example, just apply the formula. The answer may be positive or answer may be negative. If answer is positive, that means it is rightward. The velocity and acceleration are vector quantities, so it has direction. Plus shows it is rightward direction and minus shows it is leftward direction. For example, here acceleration is minus 0.25. That means the direction of acceleration is left side. Here acceleration is minus 8. Minus sign shows it is leftward. Now we have discussed about position, velocity and acceleration. Now let's discuss about distance and displacement. How do we study motion using distance and displacement? So when we study motion, we observe the speed, how fast something is moving. You see on a road, a truck is moving and car is moving. What difference you see? Between 2 points A and B, the truck takes more time because speed is less, but the car is fast. It takes less time to go from A to B. Time is less because speed is more, right? So this is something we observe when we observe the motion of objects, speed, correct? And when direction is involved, rightward, leftward, we call it velocity, right? It becomes vector quantity. So what is velocity? It is a vector quantity. It is a vector quantity, and speed, it is a scalar quantity. Both are used to study motion. Then what is the difference? The difference is direction and also distance and displacement. So how do we relate velocity, speed, distance and displacement? So first we will see the formula. We are going to write four formula. You observe when I say average velocity. So it is denoted by delta x by delta t. Delta x means displacement. Displacement. Delta t means change in time or total time taken. Total time taken. Or we can say change in position. Change in position divided by change in time. All these three have same meaning. Delta x means displacement, delta t means time duration. Then we have average speed. It is given by distance by time. We can also say total distance by total time. Total time. So when it comes to average velocity and average speed, you have to understand the difference of displacement and distance. For average velocity, we consider displacement. For average speed, we consider distance. We'll see some examples to understand the difference between these two when you do calculations. Now instantaneous velocity. Instantaneous velocity we have discussed. It is dx by dt. Now when we say dx by dt, it can be positive or negative. It can be positive or negative. When it is positive means it is a rightward direction. Rightward direction. And when it is negative, it means leftward direction. It is leftward direction. So suppose you observe car is going right side, so velocity is positive. If car is going left side, so velocity is negative. Same thing with vertical line also. If you see some ball is thrown up, so it is positive. If ball is thrown down, so velocity is downward, so it is negative. Then what is instantaneous speed? What is instantaneous speed? Instantaneous velocity, how to calculate dx by dt, but how to calculate instantaneous speed? So same formula, but we don't consider negative, it is positive only. So you can say it is magnitude of dx by dt. If dx by dt is plus 3, so speed is also plus 3. If dx by dt is minus 3, so speed is plus 3. So it is the modulus of dx by dt. So these are the formula: average velocity, average speed, instantaneous velocity, instantaneous speed. Now before studying further, let's discuss what is the difference between displacement and distance. Little bit we'll talk about these two. We'll see the difference between them and a method of calculation, how to calculate displacement, how to calculate distance, and we will come back to these average velocity and average speed also, and instantaneous velocity and instantaneous speed. So displacement is denoted by s, or the formula is delta x, which is final position minus initial position, and distance means actual length of path, actual length of path. We can say route, we can say route. When we see some movie or some when we listen some stories of detective, suppose they want to know where person is going, so they can observe the footmarks. On in a jungle, the footmarks are there, so we say, oh, person is going using this route. Or to observe the motion of some animal, maybe it is a tiger, so generally we observe the footprints or footmarks. So we can observe the route, where the tiger is going or that some person is moving. Then you calculate the length of that route. Suppose it is like this, the route is like this. Suppose this is 1 meter, this is 1 meter, and this is 1 meter. So this is the route, this is the route, this is known as route or path. So how much it is going? 1 meter, then 1 meter, then 1 meter, so that is 3 meter. So distance is 3 meter, distance is 3 meter, but displacement is not calculated like this. So what is easy to calculate, distance or displacement? It is a difficult question. What is difficult to calculate? We cannot say. We will do some exercise, then it is up to you what you find. It is easy to calculate distance or easy to calculate displacement. So let's use the straight line x-axis. This is x-axis, particle going along x axis. When I say it is going along x axis, it can be going right side, it can be going left side. Suppose x equal to 0, it is a reference, it is known as reference, or we can call it frame of reference, frame of reference. So x axis is the frame of reference with the reference at origin. Now the position is changing. So suppose if I say x is equal to t square, and the question is find distance and displacement in first 2 second. First 2 second. So let's observe the motion. If we calculate velocity, that velocity will be 2t by differentiation. So t is equal to 0 or t is equal to 1 or t is equal to 2. You put any value of time, we see that the velocity is positive. At t is equal to 0, velocity is 0. At t is equal to 1, velocity is 2. And t is equal to 2, velocity is 2 into 2, so that is 4. So these are positive numbers. So the values are positive. So velocity is positive. That means the particle is going right side continuously. Particle is going right side continuously. Continuously, it is going right side. That means what? Direction is fixed. Direction is fixed. Direction is fixed. It has fixed direction. It has a constant direction. It is a right side. On x-axis, two directions are possible, rightward or leftward. So over here, x is equal to t square. So you put any value of t, you get positive value of x, and that x is increasing. So the particle is moving right side. So let's say t is equal to 0, we say x is equal to 0. T is equal to 1 second, we can say x is equal to 1 meter. T is equal to 2 second, then x is equal to 2 square, so that is 4 meter. T is equal to 3 second, so x is equal to 3 square, so that is 9 meter. So as time is increasing, position x is also changing and increasing. Increase means change, decrease also change, but here it is increasing. So the particle is going along x-axis, right side it is going x is equal to 1, after some time 2, then 4, after some time we have 9 meter also there, x is equal to 9 meter. So position is increasing, so the particle is going right side. And we have found using velocity also, velocity is positive, that means the particle is always going right side. So when the direction is fixed, displacement and distance both are equal, but we know that distance is a positive quantity, so we can write this distance is equal to magnitude of displacement when it has a fixed direction. Fixed direction means straight line motion. It is possible only in straight line motion. Straight line motion, like for example in circular motion the direction is not fixed, right? So we cannot use this formula in circular motion. It is a straight line motion. Straight line motion we can use this formula. So suppose I am saying x is equal to t cube, find distance in first 2 seconds. So we'll put t is equal to 0, x1 will be 0, and t is equal to 2, x2 will be 2 cube, that is 8. So we'll calculate delta x. So delta x will get 8 minus 0, that is 8. So this is displacement. This is displacement, but distance is also same. Distance is a magnitude of displacement. So distance is also 8. Distance is also 8 meter. In first 2 second means 0 to 2. Displacement is 8. Distance is also 8. If we say x is equal to minus t cube, now find the distance in first 2 seconds. So first we will calculate delta x. Delta x means final minus initial. So t is equal to 0 and t is equal to 2. These are initial and final time when we say first 2 seconds. So t is equal to 0. What is x1? It will be 0, and x2 will be minus 2 cube, so that is minus 8. So what is delta x? Delta x will be x2 minus x1, so that is minus 8 minus 0, so this is minus 8. So displacement is minus 8. Displacement is minus 8, but distance will be plus 8. Distance is a positive number, so distance is plus 8. Let's do one more. Next, what if I say x is equal to t square minus 2t? Let's observe the motion first. Then we will talk about distance and displacement. So suppose this is a straight line. Here we have origin, x is equal to 0. This is also initial position, because when you put t is equal to 0, the first time I am observing this particle, so t is equal to 0, we are getting x is equal to 0 minus 0, so that is 0. So t is equal to 0, it is at origin. T is equal to 0, the particle is at origin, x equal to 0. Now let's calculate velocity. So instantaneous velocity will be 2t minus 2. Now put t is equal to 0. So at t is equal to 0, velocity is equal to 2 into 0 minus 2. So this is minus 2, velocity is minus 2. What do you mean by this? It is going left side. So left side, velocity is left side. So initially particle is at origin but going left side. So it will go left. The motion is left side. So continuously it will go left side, or after some time it will come back and it will go right side. Now one thing we observed, At t is equal to 0, it is going left. So next we will see at what time velocity is 0. At what time velocity is 0. Why we are calculating this? Because we want to observe for how many seconds it is going left side. T is equal to 0, it is going left side. But for how long, how much time it is going left side? Means the direction of motion is left side. So at what time velocity is 0? So you put 2t minus 2 is equal to 0. So 2t is equal to 2. So t is equal to 1 second. So between 0 to 1 second, it is going left side. Why? Because at 1 second velocity is 0. Now what is position at 1 second? At t is equal to 1 second, position is 1 square minus 2 into 1. So that is 1 minus 2. So that is minus 1 meter. X is equal to minus 1 meter. So that means between 0 second and 1 second, the particle moved left side. How much it is moved left side? We can find the delta x is equal to final minus initial. So minus 1 minus 0. So that is minus 1 meter. So between 0 to 1 second, the displacement is minus 1 meter. So distance is 1 meter. 0 to 1 second, displacement is minus 1, and distance is plus 1. Distance is positive, so no need to write plus. It is understood it is positive, so you can say 1 meter. Displacement is minus 1 and distance is 1 meter. After that, what is going on? At t is equal to 1 second, the velocity is 0. Velocity is 0 at t is equal to 1 second. Fine. Let's put t is equal to 1.1. T is equal to 1.1 seconds. So what is the value of V? V will be 2t minus 2. So 2 into 1.1 minus 2. So that is 2.2 minus 2. So that is equal to 0.2. Why we are calculating this? To know the sign plus or minus for velocity. So it is positive. Velocity is positive. It means the particle is going right side. If you put t is equal to 2 seconds, you see velocity is 2 into 2 minus 2. So that is 4 minus 2. So 2 meter per second. Again positive. That particle is going right side. So any value of t you put, but it should be more than 1. If you put t is equal to more than 1, for t is equal to more than 1, you say the velocity is positive. Velocity is positive. Means the particle is going right side continuously. 0 to 1 it is going left side, but 1 second onwards it is going right side. It is going right side. So the motion is represented like this. On x-axis, for 1 second it is going left side. T is equal to 1. Sorry. T is equal to 0 to t is equal to 1, it is going left side, but 1 second onwards it is going right side. Continuously it will go on. It will go on continuously. So this is known as route or the path. This is known as path followed or route followed. So we have to observe how much it is going left side and how much it is going right side. So for that we need time duration. Time duration means delta t. So let's do one question. So this is also known as U-turn. This is also known as U-turn or reversal of direction. This is known as U-turn or reversal of direction. Direction is reversed. It is going left, now it is going right. Or suppose it is going right, after some time it is going left. So direction is reversed. So let's do one question. Suppose x is equal to 2t square minus 2t. The question says find distance in first 2 seconds. Find distance in first 2 seconds. We can calculate distance only when route is known. Route is known to us. Route is known to us. Known means we know how much it is going left side and how much it is going right side. How much it goes left and how much it goes right. How much it is going left, how much it is going right. For that we have to consider velocity, because when direction is reversed, v is 0. If you observe the previous situation, direction is reversed at 1 second. So here velocity is 0. Like for example, if you throw this object like this, at topmost point velocity is 0. Direction is reversed. Before reaching topmost point, it was going up. After reaching topmost point, it is going down. So direction is reversed. Direction is reversed when velocity is 0. In 1D motion, motion along a straight line. So for that we calculate velocity first. So calculate velocity by differentiating dx by dt. So that is equal to 4t minus 2. Now put v is equal to 0. You can call it step 1. This is step 2. Put v is equal to 0. So 4t minus 2 is equal to 0. So 4t is equal to 2. So t is equal to 2 by 4, or that is 0.5. Velocity is 0 at 0.5, but the question is asking what is the distance in time interval 0 to 2. And velocity is 0 at 0.5. It means what? 0 to 0.5 second, it goes in rightward or leftward, in some direction, and 0.5 second onwards. 0.5 second onwards, after 0.5 second, it goes in opposite direction. It goes in opposite direction. It goes in opposite direction. So we'll see. So now we have a time interval 0 to 0.5 and they're asking 0 to 2. So next will be 0.5 to 2 seconds. 0 to 0.5 second and 0.5 second to 2 second. We'll calculate delta x. So delta x will be position at 0.5 second. So what is position at 0.5 second? 2 into 0.5 square minus 2 into 0.5 minus 2 into 0 square minus 2 into 0. So if we calculate this, we'll get 2 into 2 into 0.5 square, so 0.25, 2 into 0.25 minus 2 into 0.5 will be 1, and this term will be 0. So that is 0.5 minus 1, so that is equal to minus 0.5. Minus 0.5. Now let's calculate delta x for second duration, which is 0.5 second to 2 second. So that is equal to, now final value of time is 2, initial value is 0.5. So delta x will be 2 into 2 square minus 2 into 2. This is final x, then minus initial x, which is 2 into 0.5 square minus 2 into 0.5. So let's calculate this. So 2 into 4 minus 4 minus 2 into 0.25 minus 1. So 8 minus 4 minus, this is 0.5 minus 1. So 4 minus 0.5. So this is 4 plus 0.5. So that is equal to 4.5 meter. First displacement is minus 0.5 meter left side. Second displacement is 4.5 meter right side. So how far it has gone left side? 0.5 meter. How far it has gone right side? 4.5 meter. So what is the total distance? So total distance will be, we can draw the diagram also like this. Left side it is going 0.5 meter and right side it is going 4.5 meter. So total distance is equal to 0.5 meter plus 4.5 meter, that will be equal to 5 meter. Total distance is 5 meter. And the total displacement, to calculate total displacement, we can use 0 to 2. So position at 2 seconds minus position at 0 second. If we calculate this, we'll get total displacement. So that is 2t square minus 2t. So 2 into 2 square minus 2 into 2 minus 2 into 0 square minus 2 into 0. So that is 8 minus 4. It is 4 meter. Or we can use simple numbers like how you add numbers, negative and positive number. So we can also write total displacement as minus 0.5 plus 4.5, that is equal to 4. So displacement is 4 meter and distance is 5 meter.